All right. Just waiting for participants. It's Daniel Tellis, and that's the mouse for that. All right. Here we go. Okay. So 2 persons joined. We're just waiting a little bit and we're gonna start. Hey Joe. Hi. Hi there. Okay, so let's get started. So 2 people watching, they are basically my friends. All right, let's get started. Today we're gonna go through fractions and we will be able to understand how to work with them. So we're gonna do and provide basic operations, like we will learn how to add fractions, how to subtract, how to multiply, and how to divide. So all 4 basics operations here, okay? But we also start from types of the fractions, how we can categorize them, like how we can recognize what one fraction is, what another fraction is, okay? We also be able to get to know ordinary fractions, and we'll be able to provide addition and subtraction. So actually we'll get to know how to actually provide addition and subtraction, and also the idea of LCD. It means the lowest common denominator, to work better with big numbers when you have different fractions and when you have different denominators and when you have big numbers in it. And finally, we finalize with multiplication and division for fractions. Okay, that's going to be good, I think, and let's try and get started from that. Okay, so type of fraction. Which type of fraction that might be here? Okay, first of all, I just copy that and we start. So the idea of fraction, the main idea of the fraction is division. So we can consider fraction as simply a division of 2 numbers, a over b. So where a and b, two numbers, they primarily integers or whole numbers, but they might be positive, they might be negative. So that's why what we're going to do, we're going to take 4 over 5 as the fraction, and we denote the top part, which is 4, is divisible by 5. So actually we have the top and we have the bottom part, so that actually we have a division 4 by 5. Okay, so 4 by 5. The top one we used to call numerator, so that's why the top, we have specific term for that, it's called numerator, and the bottom one is denominator. Okay, so that's why we have numerator over denominator. And now it's right time to categorize. For example, in this case, 4/5, we have normal, or what is called a proper fraction. So this, what is called proper fraction. Okay? It means that the top is less than the bottom. As you can see here, 4 is less than 5. It means the top one is less than 5, the bottom one. And this is normal fraction. So actually, as you remember, the fraction represents a part of something. So for example, if we have a pizza, right? Let's say this is the pizza, and we can split this pizza into, let's say, 5 parts and take 4. Let's assume we split that and we take 4 parts out of 5. That's normally what proper fraction represent graphically. It means we're taking less than the whole, okay? So we're taking less than the whole. So that's why proper fraction is always less than 1. What if we have the top more than the bottom one? Let's take 7/6. In this case, the fraction is improper. So we assume that the top is more than 6. In this case, 7 more than 6. So that's why the top, 7 more than 6, which is the bottom one. And we used to call that improper fraction. When we have improper fraction, it means we have always more than 1. Always more than 1. So if we compare the value of this fraction and in comparison with the bottom one, so we'll get obviously the value more than 1. Okay, that's how we can categorize, and then how we can actually estimate the value. All right. So, very high. Okay, thanks for joining. And let's get to know how we can cope with improper fraction. So normally we can split in 2 parts. For example, 7/6. We can try to take one whole part and the rest, because in this case you have 7/6, so you divide it by 6 parts and take in 7. So what it means, you definitely can take 6 parts out of 6. And on top of that, there will be a residual 1/6 value. So 6/6 parts, that means the whole number. The whole number, which is simply you know, 1, 2, 3, and so on. They're whole numbers. They're basically positive integers. In this case, 1/6 is a fractional part. So this is the fractional part. And in total, 6/6 and 1/6 we can represent as one whole and 1/6. What is called a mixed number. Mixed number. Because we have the whole part and the fractional part, 1/6. So that's why we used to call that a mixed number. Okay, so, and the last type that we get to know, it's called equivalent fraction. So equivalent fraction, 1/2, and let's say 3/6. Why they're equivalent? The idea is pretty simple. Let's say you have a pizza, and 1/2 simply means that you split on 2 equal halves, right? So that this is 1/2 part, and this is 1/2, basically a half. So if you take one part out of 2, you'll get the fraction 1/2. However, what 3/6 means graphically, you can do the same. So you can go to the pizza and try to split. Now, in this case, you'll have the bottom part 6 parts. So that's why you'll split like this. 1, 2, 3 here, and the same 3 parts here. And now you're taking only 3 parts. So that's why let's say the top 3. Alright? So graphically means that you still have a half of the pizza. Still have half of the pizza. So that's why you still have 1/2. However, like graphically and by the process, what actually you were doing, you split it by 6 parts and took 3 out of that. That's why those fractions are called equivalent. So that's why you can set up the term that's called equivalent. Equivalent fractions. Alright. So those categorizing will definitely help you. Sometimes in entrance or, for example, for school entrance test, you might heard instead of improper fraction, you might heard an equivalent for that. So I'll write just in case. It's called the top heavy fraction. Top heavy fraction, which means simply that the top one is greater than the bottom one, and that's equivalent to improper. But sometimes in questions, you might meet this as 7/6, or you might be given the word top heavy. That means that the top is greater than the bottom. Okay, so we categorize them. However, there might be different category if you consider ordinary fractions versus decimals. Let's get to know what ordinary fraction means. All right, let's go there and let's compare what ordinary fraction means. Fraction. And let's compare it versus decimal. Let's start from decimal. So decimal is the fraction which will have 10 or 100 or 1,000 in denominator. Or maybe more. That might be a million. But less likely you will have this. So the top of that fraction might be any. Let's say 2/10 or 3/100 or 4/1000. In both cases, you'll have decimals, okay? So that means, one more time, the key idea is to have the bottom part or denominator similar to 10 or 100 or 1000. In this case, you can simply convert into decimal format. So decimal format. Because remember I told you that division by 10 or like by any denominator means actually division. So the fraction represents division. So that's why we can convert into decimal format just by dividing. For example, you take 2, you divide it by 10, and that's how you can present your fraction 2/10. So just in case, like I remind you how to divide by 10 or by 100 or by 1000, you just look at the number of zeros that you have in your number that you divided by, and you simply transfer decimal point by the same amount of digits. So in this case, you have 1 0, so that's why instead of 2/10, instead of 2, you'll have 0.2. Because you transfer decimal point one time. And of course, your value is dropped down. So actually, you decrease the value for that, okay? So what if you have 3/100? In this case, you do the same, you divide it by 100, and that's how you can make a decimal format. That's again, you'll have transfer decimal point twice, all right? So that's how you can convert the decimal fraction into decimal number, because all that are called decimals, and there can be written instead of the fraction. So what about ordinary fraction? So ordinary fraction is any fraction that can be written in the form a over b. Okay? A over b. So in comparison with decimal, the can be actually becomes decimal. 1b is like 10 or 100 or 1000 or even 10,000 and much more. Okay, so but there are also other there might be other bottom part, and this might be like 2 over 3 or 4 over 5. So that's why simply ordinary fraction, that the fraction that can be set up in this form, a over b. Okay, so it works pretty clear. And ordinary fraction and decimal you can consider as their private case for the ordinary fraction. Okay, so we categorized the fractions, and it's right time to know about addition and subtraction. So actually right now we need to be able to cope with operations with fractions. So how addition works and subtraction, they work in pretty the same manner. So let's consider the case 2 over 3 and we add 1 over 3. When we have the same denominators, we actually add in the top parts. So the result in this case is going to be, we leave 3, we don't add denominators, we leave as it is, we don't change. So don't change denominator, just add the top ones. Okay, in this case you simply add in 2 and 1 and you'll get 3 over 3, which is 1. Okay, how to prove that this is the case, where it comes from? Just remember the pizza. In this case, you trying to add, in both cases, you have 3 parts, so you divide pizza into 3 parts. Let's say it something like this. 3 equal parts. And for the first fraction, you taken 2 parts out of 3. So you taken those 2 parts out of 3. And that's yellow zone represents 2 over 3 out of the whole pizza. So what about the rest part? I shade with the red one. And I must say that this is only 1 out of 3 part left. So if you want to add yellow part with the red one, finally or algebraically, you'll have what's written here. It's 2 over 3 plus 1 over 3. Okay, so you'll get this. And graphically, it's obviously that to add red part with yellow zone or yellow part, you'll get the whole pizza. So that's why what are you going to do? You're going just to add the tops of the fractions. Okay, you just take 2, you take 1 and add them up. Okay, so that's why when you have the same denominators, that's not the problem. In the similar case, let's practice with subtraction. 2 over 3, you subtract 1 over 3. Simply, from the red part, you eliminate that piece. Okay? So from 2 over 3, so from yellow zone, you actually eliminate this black part, which is 1 over 3. So this is 1 over 3, and you subtracting, you're taking away. So in this case, what will happen? Obviously, you will left with 1 over 3, which is the yellow part. So that's why the logic stays the same. You take denominators which are the same, so you don't change that again. The rule is don't change the denominator, and you take away from the top of the first fraction another one. But what if, for example, you need to be able to cope with negative numbers as well? For example, let's say you taken and swap in the process. 1 over 3, you take away 2 over 3. So what do you think in this case is going to be? Okay, you'll get 3 and you subtract from 1, 2. Obviously, you'll get the negative 1 over 3. So you work normally like with numbers. Why is that? Because you stay at 1 and you subtract 2 units. So you go back here to 0 and you go back here to subtract extra 1 unit. So that's why you'll get negative 1. That's your result. So you took away 2 units. So that's why you just go into negative zone for a number line. So that's number line. So finally you will left with negative 1 over 3. So there is no problem that you got a negative number. That's definitely not the problem. Okay? So if it's okay, so because that the basics, we can go to more complicated case. How to add or subtract in case when you have different denominators. Okay? In comparison or in contrast, I'll try to show you the way how to work with different denominators. So what if denominators are different? If they're different, you need to work in 2 ways. For example, 1 over 3, you want to add 3 over 4. So the best way, when you have pretty small numbers and the bottom parts, you just doing the following. You multiply 3 by 4, so here is multiplication, and then you're doing a crisscross. So what exactly I mean by saying the crisscross? You're taking this 4 and multiply by 1, and you're taking this 3 and you multiply by 3 here. And that's why you can come to the common denominator. Okay? So 4 goes here and you multiply 1 by 4, and 3 goes here, so you adding. So this operation, addition. So this is adding. Okay? So because this adding, you're leaving addition sign here as well. So you don't change into something else. So you adding, it means you need to add 3 times 3. So that's how it works. Okay. This is the technique that you need to use during addition or subtraction of fraction with denominators to be different. So let's calculate and find out how much you'll get in this case. So 1 times 4 is 4, and then you add 9 here. Then you divide 3 by 4, you divide it by 12. Okay? If you simplify that, you'll get 4 plus 9, which is 13. And you might be asked, give the simplest form. So give the simplest form. So what it means, you need to give a mixed number in this case. So mixed number is from 13 over 12, you need to write 1 whole part and the result, the rest or remainder here as 1. So the result is going to be 1 whole and 1 over 12. Because remember, 13 over 12 is the same as 12 out of 12 and actually plus 1 part out of 12. So that's why you'll get 12 over 12 this 1 whole and 1 over 12 as the rest part. Okay? So that's typically how it goes. Okay, so the next step. I just want to show you why you can do that. Why actually you need to times crisscross. So this is technique that you need to use during solution or during solving real questions. So this is the technique, but you need to understand probably why I'm supposed to do that. So the result, the explanation for that is pretty obvious. So what if you want to add different two fractions with different denominators. So what you can do, you can say that we can make the same denominators. So 3 here and 4 here. Obviously 3 and 4, they don't have something common, like common factor. They don't have common factor, and LCM, the lowest common multiple for them, is just simply multiplication 3 by 4. So that's why our purpose is to multiply the first part by 4. And because we are not going to change the fraction, we also need to times by 4 the top one. And for the second fraction, we need to multiply vice versa. So we need to multiply by 3 and by 3 here, alright? So that's how it works. And that's why you'll have actually crisscross multiplying here and here. Indeed, you'll have 12 and 12, and you remember that you leave 12 as the common denominator. You don't change that, according to the previous that we've got before. Okay, so here on the top we have 4 times 1 and 3 times 3. So in total we have 4 plus 3 and 3 is 9. So actually we come back to this result. So that's actually sort of proofs. Okay, that's proofs why you're eligible to apply this technique. But the technique is pretty straightforward. Okay, let's have a little practice. So I'll give you 2 fractions and you try to do by your own. Okay, so for example, the first one is 2 over 5 and you add 1 over 15. And the second one, I'll give you 3 over 4, and here I'm going to subtract 1 over 3. So please guys, work out the results. So try to do by your own. I'll give you some time. So try to do that. And if you'll be ready, just drop message in the chat. So you can drop your answers here. Okay. Okay, you got the first one, 7 over 15. Okay, we'll check it soon. So what about the second one? Alright, so I can see the second one as well. So 5 over 12. Okay, so waiting for Mary. Okay, so let's try to finalize and see what exactly you have here. So 2 over 5 and 1 over 15. So actually you need to multiply 5 and 15. But hold on, we can do more wise, you know. Remember, before we need to be able to get denominator the same. So 15 and 5, we can multiply by 3. In this case, we'll have 15 in the bottom part. And that allows us to have two fractions with the same denominators. Okay? So for example, in that case, we'll get 6 over 15. And we didn't do anything with the second fraction. We still have 1 over 15. Okay? Because it's more wise to change only the denominator of the first fraction. Okay? So that's why we can add freely 6 and 1, because denominator is the same. So that's why the resultant answer here is 7 over 15. And you, John, is correct. Okay? You're correct here. All right. Let's go to the second one. So here, we're not able to make so easily the common denominators. So we can do technique that I'll show you here. So that's technique. And let's try to figure out how much it's going to be. So 4 and 3. And crisscross 3 by 3 is 9, and 4 by 1 is 4. So that's why the result is 9 minus 4 over 4 times 3. So the result here is going to be 4 over 12. And for the second one, you, John, is also correct. Okay, perfect. Let's get next. And try to understand the idea about how we can cancel the fractions. Okay? The idea of canceling is pretty straightforward. So how to cancel the fractions? How to cancel the fractions? So canceling means that we can divide one number on the top by another number in the bottom part. So for example, 3 over 6. Or if I switch back here, we've got 3 over 6, and we understand that this is the equivalent fraction to 1 over 2. So two fractions are equivalent. So we catch this idea and try to make, instead of 3 over 6, just equivalent fraction. Equivalent fraction, in this case, will have the simplest form. So that's why if we write the bottom parts 6 as 3 times 2, we actually get 1 over 2 in the simplest form. Before, I showed you actually why it's eligible to have 1 over 2 as an equivalent one. However, here right now, we simply do actually simplification. We do canceling. Cancel means to take away or cross out two numbers that are the same, that stays on the top and in the bottom of the fraction. So we take away. And actually here, like many students ask me why it's not 0 left in the bottom part. Sorry, in the top part. So actually the result why 3 disappeared means that 0 cannot be here. If you write 0 here, the result is 0. But we know that's not the truth. So that's why 1 will be left. On top of that, I may say that 3 is always can be represented as 3 by 1. So that's why when we cancel 3 here and 3 here, 1 will be left in the top part, not 0. So that's why the equivalent fraction is 1 over 2. So the idea of canceling allows to make addition and subtraction fractions made more easily. For example, instead of having deal with big numbers, we can have a deal with the following, with smallest one. So let's consider that example. 2 over 12, we add in, let's say 9 over 36. Alright, so what we can do here, we can cancel 2 and 12 and 9 over 36 before doing any operation. So that's why instead of 2 and 12, we will have the following. So 12 is simply 2 times, here, 2 times 6. Why I represent exactly as the product? Because you always can cancel when you have multiplication between numbers. You cannot cancel them like in this case. You cannot cancel them. Because in this case, you can compare the result. So the result is 2 if you cancel. But what if you add first 3 and 2? You'll get 5 over 3. And this is not equal to 2. So that's why it's illegible canceling. So you cannot do this way. Okay? So that's why you can cancel only when multiplying. So, and that's why I represent the 12 as 2 times 6. And now we can cancel 2 and 2 here. So instead of 2 over 12, we'll get 1 over 6. And the right fraction, when we're adding, we'll get not 9 over 36, but we'll get 1 over 4, because 36 in the same manner is 4 times 9. And that's why 9 and 9 on the top will be cancelled, leaving you with 1 over 4. And now we just simply do the same. So we multiply by 4 here and by 6 here. And the top parts we also multiply by the same numbers in order not to change the fraction. So here and here as well. So finally, we'll get 24 and 4, and we add 6 over 24. So the result, as you understand, is going to be 10 over 24. And now you can cancel that again. 10 over 24, you can cancel by 2, because 10 is 2 times 5 and 24 is 2 times 12. So it's right time to cancel. So both 2's will be cancelled here. So the final result is going to be 5 over 12. Okay? So that's the main idea. That's the main idea. And that's how it works. Okay? So the idea of canceling is pretty straightforward. Alright, so we got how to do that. Maybe just let's try to do by run, self-practicing. Okay, so let's take 3 over 24 and we subtract, in this case, 2 over 6. So try to figure out the result. Okay, so you're given 3 over 24 and you take away 2 over 6. So you need to get the result. Okay, so you've got, let me see, 1 over 3 minus 1 over 3, the result is 0. Yeah, you're right, because 3 over 24. Except for 1 over 3 for the first part, it's not correct, because you've got 3 over 24. How you get 1 over 3? So let's do it one more time. So 3 and 24, you can cancel because 24 is 3 times 8. Okay? And that's why both 3 you can cancel. So actually you'll get 1 over 8 for the first time. Okay? So you should get this. 1 over 8 minus 1 over 3. So the second part is correct, okay? So the second part is correct. So that's why you take away 2 over 6, you can cancel, and that means you'll get 1 over 3. And now the numbers are smaller, so that's why you can do subtraction with no problem. So 8 and 3, you multiply them, 8 and 3, and 3 goes here crisscross, so you times 1 times 3, and you subtract 8 times 1. Okay, so that's why finally you'll get 3 minus 8 over 8 times 3. Don't hurry up, don't multiply 8 and 3, just leave as it is. And 3 minus 8 over 8 times 3, you'll get negative 5 over, and now it's time to multiply 8 by 3 is 24. So the final result is going to be negative 5 over 24. Okay, so that's how it works, and that's how we can improve your actually way of doing. Okay, so that's an idea. Okay, so let's move back and try to work with greater numbers. Let's add them and take, say, 5 over 125, and then you need to add, let's say, 24 over 64. Let's try to work with greater numbers in that case. Okay, let's try to do this. Okay, so 5 over 125 and 24 over 64. Let's try to add them. Okay, so you got 1 over 25 and 3 over 8. Okay, so indeed, if you cancel 5 and 1 over 25, you'll get 1 over 25, because 125 and 5 can be presented as this one. So you you represent as the multiplication of 5 and 25, okay? So that's why you'll get 1 over 25, and on top of that, you add 24 over 64. So it means that 24 and 64 can be cancelled. And indeed, so 64 is 8 by 8, right? And the top part, 24, is 8 by 3. So I intentionally took 8 and 3 because actually you can split in different ways. Let's say 6 and 4. They will also give you 24, but how they help us in this case? I would like to cancel. So that's why instead of 6 and 4, I would use 8 and 3. So that's why I take away my wrong combination, and simply I would like to have 8 times 3 over 8 times 8. And now it's right time for canceling. Okay, and now what you're gonna do is just to say that 1 over 25 plus the rest part is 3 over 8. Okay, and that's why you done absolutely correct. Okay, so you got the principle, and it's nice. I hope other guys also got it, how to work out. And finally, what we need to do, we need to make the common denominator. In this case, 25 and 8, they're quite big numbers. And then you take an increase, so you take 8, multiply by 1, and you take 25 multiplied by 3. Okay, so that's the result, almost there. And now you need to just write more accurate. So, and now what are you gonna do? You just need to add 8 and 25 times 3. So 25 times 8, and on top you'll have 20 times 3, which is 75. And on top of that, so this is 75. And now you're going to add 8. So 75, 8, you'll get 83. So obviously 83 is sort of a prime number, because less likely that you can divide by 2, that you can divide by 3. So let's check it. So for example, 8 over 3 is not divisible, obviously. By 2 is also not divisible. By 7 is also not divisible. So definitely 83 is the prime. So you cannot cancel 83 with something in the bottom part. And what about the bottom part? 25 by 8. So I would recommend, if you do it mentally, if you guys do it mentally, so I encourage you to split 8 as 4 plus 4. It means you first multiply 25 by 4, and next you also multiply 25 by 4. So you'll get 100 and 100. So you'll get 200 in total. So that's why the result of the fraction, of the bottom part of the fraction is 200. And the one is 83. Okay, that's which results you will have right now. So 83 over 200. Okay, so that's an idea. And let's think, we'll to actually understand that what we're doing, that idea of LCD, the lowest common denominator. It's almost there. It's almost there. So it means that LCD for two fractions, let's say 1 over 6 and 1 over 12, is the idea that the lowest common multiple, some number that can be divisible by 6. Okay, so it means that you finally got LCM for 6 and 12 is 12. Understand that 12 is divisible by 12 and 12 is divisible by 6. So that's why finally, if you use 12 as the common denominator, you can understand that 12 divisible by 6 and the result is 2. So that's how you arrange 2 as the extra factor to the top. And 12 divided by 12, you'll arrange 1. So that is going to be the extra factor to the top. So finally, you'll get 2 and 1 together. So that will leave you with 3 on top and 12 in the bottom part. So that's the idea of LCD. So the lowest common denominator is an LCM, which is the lowest possible number divisible by 12 and by 6 in our case. And because now you want to understand which the factor will appear on top of the left fraction and the top of the right fraction, so you just simply need to divide LCD, the lowest common denominator, by each denominator here to arrange 2 and 1. So that's 3 over 12, or you can cancel them as 1 over 4 finally. Okay, so that's an idea. That's an idea, and that's how you can rearrange fraction. Okay, so let's try to work with a bit different one. So for example, what if you take 3 over, say 3 over 18, and you would like to add with 2 over, let's say 24. Okay, The first idea is to cancel 3, 18 and 2 and 24. And the way that 3 and 18 will give you cancelled by 3, so that means 18 is 3 times 6. So you're left with 1 over 6. And 2 and 24, you're left with 1 over 12. Okay? And now, you just simply add them using the idea of LCD. In this case, LCD is 12. So you take in 12, divided by 6, and that's how you can get the extra factor. 12 by 6 is 2. We actually added them before. And 12, we divide by 12, we'll get 1. So we multiply 1 by 2 and 1 by 1. So final, we'll get 2 plus 1 over there. And finally, the result is going to be 3 over 12, which is simply the same as 1 over 4. As you understand, both results are actually the same because we have the equivalent fractions, okay? So we've got equivalent fractions, and that's why the result in both cases is the same. So that's the idea of LCD. So the idea is actually coming from the previous case, like how we're trying to rearrange denominators wisely, okay? In other words, we're simply thinking about how we can rearrange the bottom parts in order to get the same denominators. That's almost the same idea when working with LCD. Okay.